You know that smart light bulb or that little wireless sensor in your home? Ever wonder what makes it all just work instantly? Well, there's a really good chance it's running on a quiet, super efficient protocol that you've probably never even heard of. Today, we're going to lift the hood on ESP Now, the invisible code that's powering a huge part of our connected world.
And when I say huge, I mean it. To give you an idea of the scale we're talking about, the company that created this, Espressif, has shipped over 1 billion of their main chips since 2014. That is 1 billion devices out there all needing to talk to each other.
And right there, that's the big question for anyone making these little smart gadgets. When your device runs on a tiny battery, how in the world do you keep it connected for months or, maybe even years at a time? So here's what we're going to break down. First, we'll look at the big battery problem that regular Wi-Fi creates for these devices. Then we'll see how ESP Now offers a really clever, stripped-down solution. After that, we're going to switch gears and put on our hacker hats to look for a security flaw hiding in plain sight. Okay, so let's tackle that first big problem. Why can't these tiny things just use the same Wi-Fi our laptops and phones do? It seems like the obvious answer, right? Well, the thing is, standard Wi-Fi is a beast. It's powerful, but it's also a serious power hog. It has to do all these complicated digital handshakes just to connect, and all of that takes time and, more importantly, energy. Now, for your laptop that's plugged into the wall, who cares? But for a little sensor that just needs to wake up and say, hey, the temperature is 72 degrees, it's massive overkill. What these little guys really need is to talk instantly, use almost no power, and just make that battery last as long as humanly possible. And this is exactly where Espressif came in. They saw this huge gap and decided to build a protocol from the ground up specifically to solve this one problem. So what is ESP Now? It's a connectionless protocol. That word, connectionless, is the magic ingredient here. It means devices can just fire off messages directly to each other super fast and with amazing energy efficiency, without all the ceremony of connecting to a router every single time. To really get why that's so cool, think about regular networking. It uses this formal 7-layer model. It's like every piece of data has to fill out forms in triplicate as it gets packaged and unpackaged, moving up and down these 7 different departments. It works, for sure, but it's really bureaucratic. And here's the brilliant part. ESP Now basically takes that whole bureaucratic system and just throws it out the window. It works almost entirely on one single layer. So instead of that whole formal process, it's more like passing a quick note directly to your friend. It's that simplicity that makes it so incredibly fast and efficient. Okay, that's the theory. But what does all that efficiency actually mean for a real device with a real battery? The difference, it turns out, is absolutely staggering. Some researchers at a company called ThingPulse ran a really cool experiment. They took a device and just had it do one simple thing. Wake up, send a little bit of data, and go back to sleep every 15 minutes. First, they did it with normal Wi-Fi. Then, they ran the exact same test with the exact same hardware, but swapped in ESP Now. Check out these results. With standard Wi-Fi, the battery would last just under 7 months, which, isn't terrible. But with ESP Now, it jumped to over 44 months. That is almost 4 years on the same battery doing the exact same job. This isn't just a small improvement. It's a total game changer for what you can build. So we've got this super efficient protocol running on 1 billion+ devices. Awesome. But whenever you chase performance, you have to wonder, what about the trade-offs? So for this next part, let's see what happens when security researchers put this code under a microscope. A team at Nozomi Networks did a really deep dive, and because ESP Now is open source, they could use these powerful automated tools to scan every single line of code, basically hunting for common security holes. They were mainly on the lookout for 2 things, something called an out-of-bounds read and another one called a replay attack. Now, you'd think Espressif had this covered, right? I mean, their own documentation says it pretty clearly. There's a part of the data packet called the random value field, and its whole job, supposedly, is to prevent these replay attacks. It's the built-in shield. So, here's the million-dollar question. If the defense is supposed to be built right into the system, how on earth did the researchers manage to get past it? And that brings us to the final part of our story, the vulnerability that, despite what the manual said, was hiding right there in plain sight. So, first, a bit of good news for the protocol. That out-of-bounds bug they looked for turned out to be a dead end. They couldn't actually exploit it. But that replay attack? Yeah, that was a very different story. The researchers proved it could be done.
So what exactly is a replay attack? It's actually kind of elegant in its simplicity. Step 1. An attacker just listens in and captures a valid command. Let's say it's the encrypted packet that says turn on the smart light. They don't have to crack the encryption or anything, they just have to record it. Then, step 2, they wait. And later, they just retransmit that exact same packet. And because that built-in defense mechanism failed, the light bulb gets this old message and thinks, oh, a new command, and executes it all over again.
Now, why is this a big deal? Well, imagine that packet wasn't for a light bulb. What if it was the command to unlock your smart door? An attacker could grab that command when you leave in the morning and just replay it in the middle of the night. Or they could keep replaying old sensor data to make it look like everything's fine in a factory. And the sneakiest part of this whole thing is that it completely bypasses the encryption because the attacker is just reusing a message that was already perfectly valid. When you step back, the story of ESP Now really shines a light on one of the fundamental trade-offs in all of technology. It's that constant battle between performance and convenience on one side and robust security on the other. To get that incredible efficiency, you strip things down. But sometimes, those complicated bits you stripped away were actually there for a really important reason. And that kind of leaves us with a much bigger question to think about. As we rush to connect literally everything around us, our lights, our cars, our infrastructure, we really have to stop and ask, in a world that's heading toward 1 trillion connected devices, what's the real price we're paying for all this convenience?